Assalamualaikum to all my Tholib Mumtaz students for semester 2, session 2023-2024 KMNS. In this video, I'll be explaining to you on how to solve various chemical tests in organic chemistry. So the first test is bromine in CH2Cl2, or we call it inert solvent. The purpose of this test is to distinguish alkanes from alkenes. So let's look at the first structure. You are given here an alkene or carbon-carbon double bond. When reacted with bromine in CH2Cl2, the structure will undergo electrophilic addition reaction. So the carbon of the double bond will get one bromine atom each. So this observation will be reddish brown color bromine decolorized. Next structure, you are given an alkane, which is a saturated compound. When reacted with bromine in the presence of UV or sunlight, it will undergo free radical substitution. So one hydrogen from alkane will undergo monobromination and will be substituted with bromine atom, and the side product will be HBr. So for this reaction, the observation is reddish brown color of bromine decolorized. However, the next one, you are also given an alkane, reacts with bromine, but this time in the dark or no presence of UV. So free radical substitution cannot occur if it's in the dark. So this will have no reaction. So the observation should be the reddish brown color of bromine remained unchanged. Next test is bromine water or bromine aqueous. The purpose of this test is for unsaturation test of alkenes. So when you react an alkene with bromine aqueous, each carbon of the double bond will receive one bromine atom and one OH. So this observation will be reddish brown color bromine decolorized. Next one, if you react the same bromine aqueous with alkane, it will have no reaction. So your observation will be the reddish brown color bromine remained unchanged. Next, the same test can also be done on phenol. So it is used as identification test for phenol. When you react bromine aqueous with phenol, it has to be 3 moles of bromine, and it will undergo reaction at the position 2, 4, and 6 of the benzene ring from phenol. So your product will be 2, 4, 6 tribromophenol with the side product of 3 moles HBr. So the observation for this test is the white precipitate formed. The same test can be done for the structure aniline. So this is also another identification test, but for aniline. Same method, 3 bromine aqueous will undergo reaction at the position 4, 2, 4, and 6 of the benzene ring of aniline. So your product will be 2, 4, 6 tribromoaniline with the side product 3 moles of HBr. And the same observation will occur, white precipitate formed. Next, we have Bayes test. So the purpose of Bayes test is unsaturation test for alkenes. So Bayes test reagent is KMnO4 in alkaline solution OH- in cold condition. So the first structure is given here, an alkene. So Bayes test with an alkene will produce a diol, which is each carbon of the double bond receives one OH each. So this is what we call diol. And the side product is MnO2 precipitate. So observation for positive Bayes test is the purple color KMnO4 decolorized and brown precipitate of MnO2 is formed. However, when Bayes test reacted with benzene ring, even though benzene has 3 double bonds, it doesn't behave as an alkene. Instead, it behaves as an aromatic ring. So benzene will have negative result with Bayes test, so this will be no reaction. And the observation should be purple color KMnO4 remain unchanged and no brown precipitate of MnO2 formed. Next test is called Lucas test. So the purpose of Lucas test is to distinguish between different classes of alcohols. So you have given here the first is primary alcohol when reacted with Lucas reagent, which is concentrated hydrochloric acid in zinc chloride. Primary alcohol does not have any reaction within 5 to 10 minutes. So it will be no reaction, and the observation will be no cloudy solution formed within 5 to 10 minutes. However, the next alcohol given is a secondary alcohol, which will have reaction with Lucas reagent within the 5 to 10 minutes. So the reaction will be OH from alcohol is substituted with chlorine, and your side product will be water. Observation for positive Lucas test secondary alcohol is cloudy solution formed within 5 to 10 minutes. Next structure, you are given a tertiary alcohol. So tertiary alcohol will also have positive result with Lucas test. So the same method, the OH from the alcohol is substituted with Cl from the concentrated HCl. And the side product is water. However, for tertiary alcohol, the cloudy solution form immediately. Next test is FeCl3 solution or FeCl3 aqueous. This is identification test for phenol. So when you react FeCl3 with phenol, it will be attached to the center of the benzene ring. Okay, it will be attached to the center of the benzene ring where there is the highest electron density. So this is how you draw the product. And the observation for positive FeCl3 solution is formation of purple solution. However, when you react with cyclic alcohol, which is not phenol, it will have no reaction. So the observation is no formation of purple solution. Next, we have Brady's test. So the purpose of Brady's test is to identify the presence of carbonyl compounds. So the carbonyl here is true for both aldehydes and ketones. So let's look at the first structure. You are given here a ketone. React with Brady's reagent, which is 2,4-dinitrophenylhydrazine. So when it reacts, the O from the double bond will be attached to H2 from the N to produce side product H2O. So the remaining structure, C double bond, will be attached to the nitrogen. So this is how you draw the product. So observation for positive Brady's test is orange precipitate formed. Next structure, you are given another carbonyl but aldehyde. Same process. Aldehyde, the C double bond O, only the oxygen will be attached to the hydrogen from the N inside Brady's reagent. So this will form the side product H2O. So the remaining structure C double bond will be attached to the nitrogen. And this will also have orange precipitate formed. The next structure, you are given an alcohol which is not carbonyl. So alcohol react with Brady's reagent will undergo no reaction. So the observation should be there will be no orange precipitate formed. The next test is called Tholen's test. So it is used to differentiate aldehydes from ketones. So Tholen's reagent is AgNH32 plus in OH minus. So the first structure you are given ketone. Ketone has no reaction with Tholen's reagent. Therefore, this will be no reaction. And observation will be no silver mirror formed. The next structure, however, you are given an aldehyde. So aldehyde can react with Tholen's reagent. So the way to write the product is the H from the aldehyde will be replaced with O negative. It will form a carboxylate ion. And the most important thing is here the side product, which is silver precipitate or Ag. So your observation will be silver mirror formed. Next structure, you are given another ketone but aromatic. Same thing, ketone will have negative tolerance reaction. So this will be no reaction and the observation should be no silver mirror formed. Next structure, you are given another aldehyde but aromatic. So tolerance test is positive for both aliphatic and aromatic aldehydes. So when aromatic aldehyde reacts with tolerance reagent, it will have product. Same thing, only the H from the aldehyde is replaced with O negative and Ag will be your side product. So this observation is silver mirror form. The next test is called Fehling's test. The purpose of Fehling's test is to differentiate aliphatic aldehydes from aromatic aldehydes and ketones. So this is different than the previous tolerance test, where in tolerance test it is used to differentiate aldehydes from ketones. So all aldehydes can be differentiated from all ketones. But for Fehling's test, only aliphatic aldehydes will have positive result, but aromatic aldehydes as well as ketones will undergo negative reaction with Fehling's test. So the Fehling's reagent is Cu2 plus in the presence of alkaline solution OH minus. So let's look at the first structure. You are given a ketone. So ketone with Fehling's test will have no reaction and the observation will be no brick red precipitate formed. Next structure, you are given aliphatic aldehyde. So this will have positive result with Fehling's test. Therefore, how to draw the product? Only the H part from the aldehyde will change into O negative. The C double bond O remains as it is. Your side product of Fehling's test is copper oxide or Cu2O precipitate, which gives us the observation of brick red precipitate formed. The next structure, you are given aromatic aldehyde with a benzene ring. So this will have negative Fehling's test result. So there will be no reaction and the observation will be no brick red precipitate formed. Next test is called iodoform test. So this is iodoform test for alcohol. So the presence of methyl carbinol is going to be detected. So what is the shape of methyl carbinol? CH3 CHOH. So the alpha carbon must have one hydrogen and one methyl. So let's look at the first structure. Iodoform test is I2 in the presence of OH minus. So this first structure, it has CH3 and H attached to the alpha carbon with OH. So yes, this is called methyl carbinol group. So this will have positive iodoform test, which is the methyl from the methyl carbinol is going to be changed into O negative and the OH from the alcohol will be changed into double bond O. And most important thing is that it forms CHI3 precipitate or this is iodoform precipitate. So the observation will be yellow precipitate formed. Next structure, you are given another alcohol, but this time, this alcohol only have one methyl. It doesn't have hydrogen attached to the alpha. So methyl carbinol must have one methyl and one hydrogen attached to the alpha. So when there is no hydrogen, this is not methyl carbinol group. So it will have negative result with iodoform test. No reaction should be observed as no yellow precipitate formed. Next structure, you are given cyclic alcohol. This is not cyclic alcohol, but alcohol attached to a cyclic structure. So check whether this has methyl carbinol. Alpha carbon has methyl and has hydrogen. So yes, this is also methyl carbinol. So it will have positive result with iodoform. The way to write the product is the methyl group will become O negative and the OH become double bond O with the side product CHI3 precipitate. So this should be observed as yellow precipitate formed. This next test is also known as iodoform test, but this time it is a test to detect the presence of methyl carbonyl group. So when it was for alcohols, it was called methyl carbinol group, but when it was used for carbonyl compounds, it is called methyl carbonyl group, which is a CH3 methyl attached directly to the carbonyl C double bond O. All right, so before we proceed further, there are a few corrections that I need you to make on this slide. Where the reagent of iodoform test, it should have been I2 in OH minus, not I2 plus. Please make this correction. I repeat, the reagent for iodoform test is the same as it was used in alcohol, which is I2 in OH minus, not I2 plus. Okay, let's proceed with the first structure. This is ketone, and this ketone has CH3C double bond O, which is methyl carbonyl. So yes, this will undergo iodoform test. So the way to draw the product is only the methyl part will become O negative, and the rest of the structure remains the same. The side product for this iodoform test is CHI3 or iodoform precipitate, which gives us the observation yellow precipitate formed. The next structure, you are given an aldehyde. This aldehyde also contains a CH3 attached to the C double bond O. So this is methyl carbonyl group also, which will produce positive result with this iodoform test. The way to draw the product, the CH3 of the methyl carbonyl part will be changed into O negative. The rest of the structure remains the same. The side product is CHI3 precipitate, which gives us the observation yellow precipitate formed. Next structure, you are given an aldehyde, but this time it is aromatic aldehyde. So on the carbonyl, there is benzene ring and hydrogen, but there is no methyl. So this is not methyl carbonyl group. Therefore, this structure will have no reaction with iodoform test, which gives us the observation no yellow precipitate formed. And lastly, you are given structure of ketone. This is aromatic ketone. On the one side, you have benzene ring. On the other side, you have methyl attached to the C double bond O. So this is methyl carbonyl group present. So this structure will undergo reaction with iodoform test, which the CH3 will be changed into O negative and gives us the side product CHI3 precipitate. This gives us the observation yellow precipitate formed. This next test is called Hinsberg's test. So this test is used to differentiate between primary, secondary, and tertiary amine. So let's look at the primary amine first. Hinsberg's test, there are two steps. The first step is the amine reacts with benzene sulfonyl chloride in excess KOH. So what will happen? The hydrogen from the amine will be attached to the chlorine from the benzyl sulfonyl chloride to eliminate HCl. So the remaining structure will form a bond, but the N nitrogen will become N negative and the K from KOH will become K positive. And this is how you show the bonding because it's charges. This is ionic bond. So ionic structure, the observation will be clear solution formed. Next step in the Hinsberg's test, this structure will undergo acidification with HCl. So what happened is the nitrogen will get the hydrogen again. So this structure is now going to be white precipitate formed. Next, we go for secondary amine. Same process. In the first step of Hinsberg's test, the amine reacts with benzene sulfonyl chloride in the presence of excess KOH. Again, hydrogen from the amine will be attached to the chlorine from benzene sulfonyl chloride to eliminate HCl. The remaining structure will form a bond, and this structure is going to be white precipitate formed. Next step, upon acidification with HCl, there will be no reaction. Therefore, your observation will be white precipitate remained unchanged. Next step, we have tertiary amine. Now, in this case, because tertiary amine has no hydrogen attached to it, it will undergo no reaction when reacted with benzene sulfonyl chloride in the presence of excess KOH. So, the no reaction should be observed as two-layer solution formed. However, in the next step, upon acidification with HCl, the structure will form ionic compound, which is the tertiary nitrogen will have hydrogen attached to it, which makes the nitrogen a positive charge, and it is balanced by Cl minus. So this ionic compound should be observed as clear solution formed. The last test is called reaction with nitrous acid, which can be used to differentiate primary, secondary, and tertiary amines, as well as whether the amines is aliphatic or aromatic amines. So first, the reagent for the reaction of nitrous acid is NaNO2 with HCl at 0 to 5 degrees Celsius. And these two reagents are reacted as in situ, meaning at the moment of experiment. Okay, so this is the nitrous acid formation. First, let's look at primary aliphatic amine. When react with nitrous acid at 0 to 5 degrees Celsius, it will form four products. The first one is alcohol with the OH replacing the NH2. The second is chloroalkane, again the Cl replacing the NH2. The third product is an alkene, where the one hydrogen from the structure is eliminated. And then lastly, nitrogen gas, which gives us the observation for primary aliphatic amine, gas bubbles formed. Next one, for primary aromatic amine, given here is the structure of aniline. When reacts with nitrous acid, it will form a structure that we call benzene diazonium salt plus NaCl and 2H2O. Now, because benzene diazonium salt is a relatively stable compound, it will not break down or decompose to form nitrogen gas. That's why our observation for primary aromatic amine is no gas bubbles formed. The next structure, you are given secondary aliphatic amine. When react with nitrous acid, only the hydrogen from the secondary amine will become N double bond O. This is called nitroso group. So the nitroso with side product H2O will give us the observation yellowish oil formed. Same goes for secondary aromatic amine. Even though there is a benzene ring here, this will have the same reaction with nitrous acid. Only the hydrogen from the secondary amine becomes nitroso, which is N double bond O. With the side product of water, this observation will be yellowish oil formed. The next reaction of nitrous acid is with tertiary aliphatic amine. So when this reacts with nitrous acid, it will form two different ionic compounds. The first compound is when hydrogen is attached to the tertiary nitrogen, which now makes the nitrogen with positive charge, and it is balanced with Cl negative. The other ionic compound is N double bond O attached to the tertiary nitrogen. N double bond O is called nitroso. So when this nitrogen has four covalent bonds, this is now nitrogen with positive charge. It is balanced by the chlorine negative. So these two ionic compounds gives us the observation clear solution formed. Lastly, nitrous acid reaction with tertiary aromatic amine, it will give us only one product, which is N double bond O or nitroso attached to the para position of benzene ring. So the nitrogen is attached to carbon number 1 of benzene, but the nitroso attached to carbon number 4. So this is known as para position. And this structure gives us the observation green precipitate formed.